Okay, well today's project is to get this little Onan generator running. This is a 1000 watt, 120 volt Onan electric plant. It was sold by Fairbanks Moores. Give you a shot of the tag here. It's a model 101-103. I'm pretty sure it's a 1950s model. I don't quite know how to read these serial numbers here, but I think that would be 55. I'm not quite sure. But yeah, 120 volt. What are they listed at? Oh, 115 actually. 1000 watts, 60 cycles. So it's an AC plant. I picked this up in July in a package deal for another Fairbanks generator set. This one I didn't have too much interest in, but I thought it was a pretty nice looking original piece. It's the little cart that it's on is actually an original Onan accessory for this unit. It's pretty simple. It's just a little axle, two little tires, a piece of sheet metal, and this little tubing handle here. But it is original. It's manual start only, no electric start. So the goal with this is to get it running, make it run pretty well, and take it up to the Jacktown show this coming weekend and sell it. I got a lot of projects sitting around, and I figured this is a good unit that somebody would be interested in. Pretty much, well, mainly because it is in pretty good condition. There's a few flaws though. Supposed to be a little stop button right here. This is the magneto ground, I believe. It's supposed to attach to it. That's missing. The spark plug lead here, I believe, is supposed to come out through this hole. So I'll put a new terminal on there. I don't know why the wire itself is so long. That might find something out in there we don't want to see. But other than that, the other major, or maybe not so major problem is that I noticed that the intake pipe flange here has a broken off ear. See the crack right there? So that flange broke at some point. I'm surprised that the carburetor's not damaged, because that's just pot metal. The iron flange actually broke. But it seems to be holding relatively sturdy. Just put a washer under that bolt. So I don't know, I might try to repair that, I might not, I might just put it back like it is if I can get it to seal well. Other than that, the gas tank is pretty rusty on the inside, but it seems structurally solid, so I might be able to just take that off and clean it out with some gasoline and some nuts and bolts. So we'll see, new piece of fuel line there. And of course we'll pull the end bell off and make sure the brushes are free in the holders and they're not gouging the commutator or the slip rings. So I'll keep you updated. Okay, so the teardown continues. Fuel tank is off. I don't think I'm going to be able to show you guys what that looks like on the inside with this camera. It's just not going to work. Looks like we got a mouse nest here in the behind the generator end bell. But the slip rings look good. They'll clean up well. Can't hardly see the commutator. It's going to be a bit of a pain to clean. Where is it? Right back there. A little bit of green corrosion, but should clean up just fine. The I don't know, looks like something might have smacked that that voltage resistor right there, that wire ram resistor. Hopefully it's not damaged. Got the shrouds off the engine here. The engine does turn. It's a bit snug. I don't want to turn it very far until I get the brushes lifted off the slip rings and I get some oil down the cylinder there. So work continues. Alright, so I've gotten the spark plug out, threw some oil down the cylinder, made sure all the brushes were free in their holders. I kind of I moved the springs over to the side so that the brushes are not dragging on the dirty slip ring in the commutator, just so I can turn it over without having to worry. And I figured I'd pull the flywheel off and clean the points up. Believe it or not, looking at this actually did have some spark, some ignition spark. It was very weak, but those ugly points there did produce a little spark. So we're going to go ahead and clean all this up. Yeah, clean all that up, test that condenser, probably end up replacing it just so we don't have to worry. Okay, continuing on. I think I've got the ignition cleaned up pretty well. Had to replace the condenser. This one here, I believe, what's that? 0.2 microfarad at 300 volt. Well, this was reading like 0.56 microfarad across my meter there. So I put in one of these. I've got a whole pile of these. These are 0.22 microfarad at 400 volt. So they are a pretty close replacement, and they seem to work on just about any small engine magneto. Unfortunately, they are just like an inline condenser. I got two leads coming out the end there. So one goes to ground, the other one kind of goes into this ugly little heat shrink ball here. So I've got the insulated lead from the condenser coming up into here along with the insulated point, the kill wire, and the primary side of the magneto coil. So let me throw the flywheel on and we'll see what kind of spark we have. Alright, with the flywheel back on, we can take a quick look at our spark here. The gap, the recommended spark plug gap is pretty narrow. According to the instructions, it's about 20 thousandths. So that's what I have it gapped at, I don't know if you can tell. Got a pretty good spark there. So let's press on. Okay, well, we got the carburetor removed, and you can see that little that section missing from the flange here. Here it is, right? Luckily the piece is still here. So if I wanted to, I could braze that back on there. That's really delicate though. I think I'm just going to leave it alone. Just return it just like it was. It seemed to work just fine. Leave that for somebody else to work on. So now that that's removed, I also took the little cover off for the flicker points here. And I discussed this in another video a couple months ago on the PE88 Onan generator. And I posed the question is, what exactly the function of these are. And I got a lot of responses, and in doing some research and really just reading the Onan literature on these units, the flicker points are timed with the engine, and they shunt out a field resistor so that when the engine's on its power stroke, the resistor is in the circuit, and that limits the output voltage. And when the engine is not on its power stroke, when it's on its when it's on its exhaust or intake stroke or compression stroke, the flicker points shunt the resistor out so that the resistance is out of the circuit. That boosts the field voltage and thus the output voltage during those 3 revolutions, or rather those 3 strokes, to prevent literally flickering in the output voltage, which could lead to flickering in lighting and things like that. Things that would be annoying, to see pulsing. And being this is a single cylinder engine, it would be especially noticeable because you've got a whole revolution where the engine's not making any power, but the load is still applied, slowing it down. So we could talk more about that later, but the other thing I wanted to show you is the thermostatic choke that this unit has, which is pretty neat. Here's the air filter, the intake pipe. The choke is right here in the center, and then this slips onto the carburetor. This is a spring-loaded choke, and there's this little like bimetallic spring up here. And that spring sits right up against the flange here on the exhaust pipe. And It's kind of difficult to do this one-handed, but you see the choke is spring-loaded. I don't know if it's, I'm guessing it'd be spring-loaded to closed or partially closed. And then as the spring heats up and the metal expands, it opens the choke, which is a neat feature. I don't know how well it's going to work, but we'll see when we get it running. So let's pull the carburetor apart. Okay, so here's the Zenith carburetor, pretty well disassembled. I left the throttle shaft in. I don't really see any reason to take that off. I did have to take the linkage arm for the governor shaft off just to get the float ball cover off. But that's just this little brass piece that clamps on there. It came apart pretty easily. It was full of water, so that's interesting. Not too badly corroded though. But I'm going to put it in one of these Berryman carburetor dip buckets for a while. I got to run out to Tractor Supply and buy an inline fuel filter. I can't believe I don't have a new one sitting on the shelf, but I don't, so gonna have to buy one. So we'll let that sit a while, and before I go, I'm gonna check on the gas tank and see how that's coming out. You see the inside of that tank now? It's looking pretty good. Well, it's not looking that great, but certainly a lot better than it was. You can see clear metal on it, or clean metal. It's probably good enough to use with a fuel filter, but I'm going to leave it sit with some gas in it while I run out and grab a fuel filter and come back and work on it a little bit more. See if we can get it a little bit more clean. Alright, well I figured since I'm going to Tractor Supply, I'll show you what I'm taking. This is another project I picked up recently. This is a 1974 Super Beetle. So, pretty much bought this to be a driver to literally do this kind of job. Run a Tractor Supply or run to the grocery store or something like that. Just so I don't have to bring my pickup truck, because pickup truck sucks down gas and it's kind of a pain to drive in crowded areas. So, this, it's running and driving, you know, it's not a bad little car. Again, it's a 74 Super Beetle. It's got the 1600 cc engine in it. Regular 4-speed transmission. So I work on it when I get the chance, when I have time. Eventually I think I will paint it and clean it up a little bit. But yeah. Always got projects going on. Okay, well I made it back with my fuel filter. Let's take a look at how the carb's doing here. Pull it out of our bucket. Float's floating, that's good. Looks okay. Seems to be cleaning up pretty well. Pliers here. Yeah. All that dirt and everything should wipe right off after the soaking here. Yeah. Yeah, probably spray that down with some gum cutter. Rinse that dirt off of there. The jets and everything look okay. Leave that in there for a little while yet. In the meantime, see if we can clean the brushes and the slip rings and the commutator. Alright, well the slip rings and commutator came out pretty well for not being able to have very good access to them. There's still some staining on the rings, but nothing that's going to matter. It's not where the brushes ride. So, and the same for the commutator. I don't even know if you can see it back there. Just barely. You see there's some green staining, a couple of marks, but you know, it's not going to matter for this unit at all. Should be able to start it up and make power without any issues. The only real issue it may be a non-issue, is that the flicker points here, what we have is got two stationary points, which they're parallel. There's a jumper between them. And then on the this piece of spring steel here, there were originally two adjoining or mating points there. You can see, maybe you can't. See, there's one missing, the one nearest to me. And there's a hole in the spring steel there. So I just took a file and ran it through the point that's still present. As far as the one that's missing, I'm not going to do anything with that. I'm going to leave it alone and see how it operates. So I'm going to put the end bell, the generator back on, and I'm going to put the fuel tank back on. That's cleaned out. And then then I'll put the front shroud on and then reassemble the carburetor. Alright, well, it's all back together. I think I got everything to the point where it should start up and make power with a little bit of adjustment required just to bring it up to spec. So a couple of things I noticed putting it back together was there's a spring inside beneath this cast iron governor arm. Can you see it up there? Maybe not. Maybe you can't see it. But that was bent at an angle. It's kind of strange. There's a post coming out of the block that's sticks up in this rear of this cover, and the spring is compressed by that post and a washer that's on the end of this thumb screw. So the tighter you make the thumb screw, the tighter the spring tension is, and the faster the govern speed. So I have the screw not all the way backed out. That's completely backed out. But we'll put it, turn and a half in, 2 turns in. Start it up and check speed. Carburetor came out pretty well. I put it back together. Had to file the cover plate here where the 2 screws hold the cover down because that pot metal had warped. So made a little gasket for it. Hopefully that doesn't leak too bad. I imagine it's going to seep a bit through that gasket because it's still not perfect. But it's about as good as I can get it without going crazy. So new fuel line, fuel filter there. I was able to clean the petcock here, so hopefully that seals pretty well. So yeah, I'm gonna, it's got fresh oil in it as well. Got a replacement spark plug. So I'm gonna put it down on the ground and see if it'll fire up. Alright, well, little Onan's running. No fuel leaks, that's a plus. adjustment. Could help that droop. But that's not too bad considering, you know, 60% load. And it hasn't been running who knows how long. A little bit jittery on that part. Both of those tires are flat. The tubes in them are just disintegrated. The thermostatic choke worked quite well, actually. Believe it or not, the first time I started it, it was one pole. Then after about 20 seconds, 30 seconds, the choke was wide open. See the heating element glowing over there, doing work. All in all, it's a nice little unit. I'm kind of on the fence about selling it now. We'll see. I'll take it up there to show and put a price tag on it. If somebody's interested, we can make a deal. I don't know how long this video is, but I appreciate you sticking with it if you have. Let's cycle the load a few times. I don't notice any oil leaks yet, but it's only been running for a few minutes. I think I said early on that I thought this was a 1955. I think it's older than that. It might even be a 45. I'm not 100% certain. I have to re-educate myself on the Onan serial number identification. It's a little bit noisy, but a better muffler would help with that. Still didn't do anything about the stop switch yet. Yeah, I'll look around, see if I can come up with a little switch that'll snap in there. You know, that almost looks like a doorbell push button, about that size hole. That's maybe about 5/8 or so. And a doorbell push button would actually work perfectly, because it's a normally open switch, and that's what the cutout switch would be. Push and hold grounds the ignition circuit. I think some little doorbell push buttons have a little light bulb in them, so I'd probably have to cut that out of the circuit. So, but yeah, I might see if I can come up with something like that. So again, thanks for watching.